Table 1.1 Measurement units for digital data. Unit description. Unit description KB kilobyte. 1 kilobyte equal to 1024 bytes. PB petabyte. 1 PB equal to 1024 terabyte. MB megabyte. 1 MB equal to 1024 KB kilobyte. EB exabyte. 1 exabyte equal to 1024 petabyte. GB gigabyte. 1 GB equal to 1024 MB. Zettabyte ZB 1 ZB equal to 1024 hexabyte. 1 TB terabyte. 1 TB equal to 1024 gigabyte. YB octabyte. 1 octabyte equal to 1024 zettabyte. 1.3.2 Types of memory. Human beings memorize many things over a lifetime and recall from memory to make a decision or some action. However, we do not rely on our memory completely, and we make notes and store important data and information using other media such as notebook, manual, journal, documents, etc. Similarly, computers have two types of memory, primary and secondary. A. Primary memory. Primary memory is an essential component of a computer system. Program and data are loaded into the primary memory before processing. The CPU, Central Processing Unit, interacts directly with the primary memory to perform read or write operation. It is of two types. 1. Random access memory RAM and 2. Read only memory ROM. RAM is volatile, that is, as long as the power is supplied to the computer, it retains the data in it. But as soon as the power supply is turned off, all the contents of RAM are wiped out. It is used to store data temporarily while the computer is working. Whenever the computer is started or a software application is launched, the required program and data are loaded into RAM for processing. RAM is usually referred to as main memory, and it is the faster than the secondary memory or storage devices. On the other hand, ROM is non-volatile, which means its contents are not lost even when the power is turned off. It is used as a small uh, but faster permanent storage for the contents which are rarely changed. For example, the startup program bootloader that loads the operating system into primary memory is stored in ROM. B. Cache memory. RAM is faster than secondary storage, but not as fast as the computer processor. So, because of RAM, a CPU may have to slow down to speed up the operation of the CPU. A very high speed memory is placed between the CPU and the primary memory known as cache. It stores the copies of the data from frequently accessed primary memory locations, thus reducing the average time required to access data from primary memory. When the CPU needs some data, the first examines the cache. In case the requirement is met, it is read from the cache. Otherwise, the primary memory is accessed. Think and reflect. Suppose there is a computer with RAM but no secondary storage. Can we install a software on that computer? C. Secondary memory. Primary memory has limited storage capacity and is either volatile RAM or read only ROM. Thus, a computer system needs auxiliary or secondary memory to permanently store the data or instructions or further future use. The secondary memory is non-volatile and has larger storage capacity than primary memory. It is slower and cheaper than the main memory, but it cannot be accessed directly by the CPU. Contents of secondary storage needs to be first brought into the main memory for the CPU to access. Example of secondary memory devices include hard disk drive, HDD, CD or DVD, memory card, etc., as shown in figure 1.7. However, these days there are secondary storage devices like SSD which support very fast data transfer speed as compared to earlier HDDs. Also, data transfer between computers have become easier and simple due to the availability of small sized and portable flash or pen drives. 1. Pen drive, hard disk, HDD, CD or DVD, memory card, tape drive, solid state drive, SSD, storage device. 1.6. 1.4. Data transfer between memory and CPU. Data needs to be transferred between the CPU and primary memory as well as between the primary and the secondary memory. Data transfer between different components of computer system using physical wire called bus. For example, bus is used for data transfer between a USB port and a hard disk or between a hard disk and main memory. Bus is of three types. 1. Data bus to transfer data between different components. 2. Address bus to transfer address between CPU and main memory. The address of the memory location that the CPU wants to read or write from is specified in the address bus. And 3. Control bus to communicate control signals between different components of a computer. All these three buses collectively make the system bus as shown in figure 1.8. CPU, memory, input and output, control bus, address bus, data bus, system bus. Figure 1.8. Data transfer between components through system bus. As the CPU interacts directly with main memory and data enters from input device or the data to be accessed from hard disk needs to be placed in the main memory for further processing. The data is then transferred between CPU and memory using bus. The CPU places on the address bus the address of a main memory location from which it wants to read data or to write data. While executing the instruction, the CPU specifies the read or write control signal through this control bus. As the CPU may require to read data from main memory or write data to main memory, a data bus is bidirectional, but the control bus and address bus are unidirectional. To write data into memory, the CPU places the data on the data bus, which is then written to specific address provided through the address bus. In case of a read operation, the CPU specifies the address and the data is placed on the data bus by dedicated hardware called memory controller. The memory controller manages the flow of data into and out of the computer's main memory. 1.2 1.5 Microprocessor. In earlier days, a computer CPU used to occupy a large room or multiple cabinets. However, with advancement in technology, the physical size of CPU has reduced, and it is now possible to place a CPU on a single microchip only. A processor CPU which is implemented on a single microchip is called microprocessor. Nowadays, almost all the CPUs are microprocessor. Hence, the terms are used synonymously for uh, practical purpose. Microprocessor is a small size electronic component inside a computer that carries out various tasks involved in data processing as well as arithmetic and logical operation. These days, a microprocessor is built over an integrated circuit comprising millions of small components like resistors, transistors, and diodes. Microprocessors have evolved over time in terms of their increased processing capability, uh, decreasing physical size, and reduced cost. Currently available microprocessors are capable of processing millions of instructions per millisecond. Table 1.2 lists different types of microprocessor along with their generation, time period, and underlying technologies since their in inceptions in early 1970. Table 1.2 Generations of microprocessor. Generation era, chip type, word size, maximum memory size, clock speed, cores. Example: first, 1971 to 73 LSI 4 or 8 bit 1 KB 108 kilohertz to 200 kilohertz single Intel 8080. Second, 1974 to 78 LSI 8 bit 1 MB up to 2 megahertz single Motorola 8 6800 Intel 8085. Third, 1979 to 80 VLSI 18 bit 18 MB 4 megahertz to 6 megahertz single Intel 86. Fourth, 9081 to 95 VLC 24 bit 4 GB up to 133 megahertz. Single Intel 80386, Motorola 868030. Fifth, 1995 to till date, SLSI 32-bit 64 GB, 533 megahertz to 34 gigahertz, multi-core, platinum, Xeron, Hexon. Few prominent examples are included.